I am still on page 201, and we're looking at that core structure problem in the margin. It's not really a problem, it's just a story, and it contains a lot of theory. So I definitely want to go over this with you. There are some new pieces of information that I haven't told you before, so we need to cover this example to get those. So I'm looking at page 201 in the margin. This is about making use of structure. You can use the structure of a linear graph to determine general information about key features of linear graphs. For example, a linear graph could be vertical, horizontal, or neither. If the graph is not vertical or horizontal, it will rise from left to right or it will fall from left to right. So to show you the structure of a linear graph, I want to paste in, that's not a linear graph, excuse me. Let's draw one. I thought I had one in. Let's just sketch a little coordinate plane. It doesn't need to be very large. Let's just go 3 in all directions. All right, so the first situation that they talk about is a horizontal linear graph. So let's put this right here and try that again. This is a horizontal line linear, where if it's horizontal, the slope will be 0. And the y-intercept will be at positive 2. So 0, positive 2, with 0 slope. There's no steepness to the line. Now recall the formula for a linear equation. Y equals mx plus b. So we would say the slope is 0, baby b in this one would be 2. Okay, let's draw another coordinate plane and see what we can do here. This time I want to draw a vertical line. So let me use a contrasting color. So let's put a vertical line right here, about right there, vertical. Now, this is something that we've sort of indirectly talked about, but I need to make sure that you understand it. In this situation, there is no y-intercept. There's no baby b to be found. This is going to be -2, 0. So because there is no baby b, there's no steepness to this line, we would say that slope is undefined. And here's really the reason for that. Remember that slope is rise over run. Well, in this case, we could calculate slope with rise. We know the rise, but there is no run. There's no movement left or right. So that would mean that we would be dividing by a 0. And in math, you cannot do that. If you put a number divided by 0 in your calculator, you'll get an error message. So this is an error in math. You cannot divide by a 0. If you do that, in this case, it's called an undefined slope. Okay, let's look at another example of a linear equation. So let me draw another coordinate plane. I believe I can use a little bit wider on this one. Sorry. So a 3 by 3, that's a good size for this illustration. And this time I want it to have a positive slope. So let's let it pass through origin. Okay, and I can calculate the slope by saying rise over run. You rise one, you run one. You rise one, you run one. So this is slope of rise over run is 1 over 1, or 1. Slope is positive. And both the y and x intercepts are at 0, 0. And then one more. Let's put a negative slope in that passes through origin. This is all pretty much stuff that I've already told you. We're going to get to the part that I haven't told you. Okay, so here comes a negative slope through the origin. So there's the intercept, 0, 0. And this time, it's the same concept of rise and run. We are going to drop 1, run 1. Drop 1, run 1. So slope is drop 1, run 1. Slope is negative, negative 1. So we would say that this line has a negative slope. Okay, so the one that does not have a baby b value, doesn't have an intercept on the y-axis, is going to be the second one, the vertical slope. All right, let's take a look at the second part of that story, under the graphs. From these possibilities, you can see that all linear graphs have 1 or 2 intercepts. Now you try. Think about the structure of a quadratic graph. Visualize or sketch the different possibilities. What are the possible numbers of intercepts for a quadratic graph? And I already drew one, so you wouldn't have to wait on me to draw this. So this is a quadratic graph. It is a parabola, and this is the part that I need to explain to you. A parabola has a standard pattern. Just like up here we had slope-intercept form, well, a parabola has its own form. And you need to know what that is to understand something here. So it is going to be y equals ax squared plus bx plus c. So this is the general pattern for a quadratic equation. You've learned lots of patterns. So let me come up here. This was, remember, the pattern that we named slope-intercept. And this one works for a linear function. The quadratic equation is going to happen when you have an x power, the highest power of 2. Okay? Now, here's something that you need to realize. The c in this equation is the y-intercept. So this would be 0c. All right? And the thing that's true about a quadratic equation is there will always be a c. it may be 0, but you'll always have one. You will always reduce your formula, or you could reduce your formula to the point where y is c. Let me show you that, how I would do that. So let's take the graph of a quadratic equation. And let's let x be 0. Okay, so let's plug it in. We have x is 0, so we have a times nothing squared plus b times nothing plus c. So this would become 0, because when you multiply by 0, you're going to get 0. So this ultimately simplifies to y equals c. So you can never eliminate c. That's what I'm trying to say. A quadratic equation will always have a y-intercept. Okay? So we know that it will always have a y-intercept. One y-intercept. But we need to figure out how many x-intercepts it could have. So with that in mind, let's take a look at this graph again. And this time I'm going to do some moving around. Okay. So in this case, let me just go ahead and show you. There are 2 x-intercepts right here. So this has 2 x-intercepts. So what about this one? Bear with me a second. Let me get it on the line so it's not going to mess with our heads. What about this one? How many x-intercepts does that graph have? It has none because it's below the x-axis. Not none. Let's say no x-intercepts. Okay, so let me just leave it there. Well, let's think, could we have... No, I'm going to leave it there because I don't want to get us into something confusing. So here is the different possibilities for x and y-intercepts. A parabola like that will always have one y-intercept, and it can have different numbers of x-intercepts depending on how it is positioned on the coordinate plane.